Hello and welcome everyone. My name is Peter Robinson. Today I've got Niraj here who's going to tell us all about NFTs and the NFT ecosystem. And so Niraj, why don't you introduce yourself a bit before you start presenting your slides so people have a better idea of who you are.
Sure. It's nice to meet you, everyone, and thank you for having me at the Ethereum Engineering Group. My name is Niraj. I'm the founder of a company called Moonstream. And basically what we do is we help projects, mostly blockchain games, sort of build, manage, and secure their blockchain economies. I'm originally a mathematician, and I've been quite active, building things on the blockchain since about 2016. Initially more focused on the infrastructure side of things, building nodes, node infrastructure, and so on. And then gradually I've sort of moved my way up into the application layer. A lot of the technology that we build, so we build everything open source actually at Moonstream, and most of our technology is actually built on, we build static analyzers and we build code generators that help people interact with smart contracts, and then that's sort of the basis of everything else that we do. We run our own nodes, we crawl our own data, and so on. And because we're so active in these different NFT economies, we spend a lot of time thinking about NFTs. And basically what I'm going to share with you is some of the stuff that we've discovered about the Ethereum NFT markets. And we're in the process actually of building on the initial research. So we've also started analyzing NFT markets on chains like Polygon. So essentially Ethereum L2s as well. Yeah, that's me, and that's Moonstream.
Okay, thank you. So with that background, you're well qualified to give the talk today. So please present your slides.
Okay, sure. All right. Does everyone see my slides?
Yes.
All right. Great. So yeah, it's actually quite an interesting date, 2022-22. And I'm going to talk about basically the Ethereum NFT ecosystem and Ethereum sort of related NFT ecosystems. Yeah, actually, I just introduced Moonstream. Maybe I can tell you a little bit more about Moonstream. So we launched as a product last September, and we published our first NFT sort of market report in November. Since then, we've gained a lot of users actually, and that caused a lot of problems. So we're in the process of doing our second NFT crawl across, Ethereum and Polygon. And the fact that we can't use our nodes anymore because we have actual users using our nodes. So we've had to use Infura and Alchemy and stuff to do our crawls. But anyway, this is Moonstream. We build everything open source. So I've put some links on these slides. I believe, Peter, that you'll make the slides available after the talk, right? So if somebody wants to visit the links.
Yeah. I'll put the PDF up as part of the description on YouTube.
Okay, thank you. So all of our code is open source. We make it a point to release all the data as, to the extent that it's presentable publicly. We usually put it on Kaggle, and that Kaggle link will take you to our data sets. And we have an openly accessible Discord community where if you want to talk to us about anything, or if you have questions, for example, about this talk or about the NFT work that we're doing, you can feel free to join our Discord and ask us. In all of these channels, my name is Zomgling. So if you look up Zomglings, you can just message me, and I'm happy to respond to you at any time. But yeah, that's Moonstream. And yeah, as I said, we published our first NFT report at the end of last October, so just a few months ago. And this was us, as I said, we build our tools. Our tools are based on sort of static analysis and code generation. And sort of at the core of Moonstream, what we do is we just crawl the blockchain. We crawl the Ethereum blockchain and other blockchains as well. And the mempool and their mempools and transaction pools, and then we just make those data sets and make those data sets queryable and expose them through our APIs. And the rest of Moonstream is sort of built up on top of that core functionality. And the way that we do the crawls is we actually have a crawler generator. So for example, let's say that you deploy a smart contract onto the Ethereum blockchain, and you want to set up some sort of monitor on that smart contract or something like that. You just come to Moonstream with the ABI, and you just tell Moonstream that here's a contract and this is the ABI, and it just generates a crawler for that smart contract given the ABI, and then you can build sort of like queries and dashboards on top of that. But that's the basic functionality that we offer, like at the foundation of everything. And we were putting that crawler through its paces, and as part of putting the crawler through its paces, we decided to let's do just a public survey of the NFT markets, and that's what ended up being our NFT market analysis, the version 1 of that research. And the data set that we crawled was basically all the NFT activity between April 1st of last year and September 25th of last year. And we wrote a small paper about it, which is available on our GitHub as well. So if you look at our GitHub, yeah, the information is all over here. I don't know how to go back into full screen mode. I think if I hit F11, it should work. There we go. Okay. And the data set is available on Kaggle. Just so if you go to Kaggle, it's about 7.4 gigabytes worth of data. You can play with it on Kaggle or download it and work with it locally if you want. So that's the version 1. The way that we collected the data. So basically, what I'm going to do is I'll describe how we collected the data for version 1 of the data set. Some of the interesting things that we found from that data, and what sort of follow-on questions we had from that work that we're in the process of answering right now. And I'll describe sort of how we're also going about answering sort of those additional questions that we had. The constraint that we put on ourselves is that we're only using on-chain data to do this analysis. So we're not using APIs, like we're not using the OpenSea API or any like central APIs. Everything that we do from on-chain data. And this introduces a few challenges. For example, it's difficult to actually put a value on NFTs, or to even like, I'm not even talking about estimate value. I'm talking about actually like trying to understand the value at which a purchase occurred, because oftentimes, and this is very common on like, for example, on the Ethereum L2s, for example, on Polygon, the transfers won't actually involve the currency native to the chain. It'll involve wrapped Ether or some other ERC20 token. So in version 2 of the data set, we're actually addressing those problems by also crawling all the ERC20 transactions, events that occur in the same transactions as the ERC721 transfers. But there is like a certain amount of work that goes into trying to ascribe a value to like an NFT transfer. And that's just like one of a whole slew of issues that occurs, when you're trying to get this kind of information purely from on-chain data. So I'll discuss those things as well, hopefully in more detail as we move forward. Okay. But the way that we built our first data set was actually quite simple. We just wanted to understand, what can we tell just from NFT transfers on the Ethereum blockchain. So we crawled just a very simple API, an ABI, sorry, the ABI consisting of the ERC721 transfer event, which I've written over here. This is the sort of Solidity representation of that event. And as I said, we did our analysis from April 1st to September 25th with this starting block and this ending block on the Ethereum blockchain, just because that's what we could do in 2 weeks in terms of crawling the data and preparing it and analyzing it. So there's no other significance to those block numbers. What we did with the data was we crawled the raw transfer events from our nodes, and then we tried to estimate the market value of each NFT by just looking at how much Ether was transferred in the same transactions as each of the ERC721 transfer events. This isn't a very precise way of calculating, of actually doing this calculation, because, for example, even like, OpenSea does batch transfers. And if you do a batch transfer on OpenSea, actually Ether is exchanged as part of the batch transfer, but there are multiple transfer events that happen as part of the batch transfer. So for example, if you bundle your NFTs on OpenSea, let's say I bundle 2 NFTs on OpenSea, and I sold that bundle, then the transaction in which that bundle got sold would have 2 ERC721 transfer events fired as part of that transaction. And it would have, a single amount of Ether transferred, from the purchaser to the seller. And it's hard to decompose, like, how that value breaks down in terms of, which NFT was worth how much Ether. So that's sort of a complication over here that in the version 1 of the data set, we didn't find a good solution for, and even in version 2 of the data set, we don't know exactly how to solve that problem. So if anyone has any ideas, I'd love to hear them. And then we also calculated at the end of our window. So as of block 13,296,011, who was the current owner of each NFT that was sort of transacted during our analysis window. And then we also calculated sort of these transfers in and transfers out aggregate statistics, so we could understand how active each address was that was active in our analysis window. So these were the tables that we derived in our data set. So our data set is one big SQLite file, and it contains these tables that you can use as the basis of further analysis. And there are a few Kaggle notebooks. People have been using these to do all kinds of interesting analysis. So if you go on Kaggle and look at the data set, you can find notebooks in which other people have sort of taken the data set and done even more interesting work, built on the initial analysis that we did. The way that we sort of built the data set, because this might be interesting to you, because you might want to build similar data sets, not necessarily for ERC 721 tokens, but maybe for other contracts and other interfaces, is well, we have a database into which we're crawling sort of raw transaction information and raw block information and this other information given an ABI, which contract methods were called by whom and when and so on. So we use the database, but we also had to use the nodes, because right now we don't crawl transaction receipts into our database. And for the ERC 721 transactions, it was useful for us to have access to transaction receipts. So our crawling involved not just looking up things in the Moonstream database where we have our own index of all Ethereum transactions, but also we had to go back to the nodes to get some additional information for stuff that we're not crawling into our database, just because it would be too much data, right? Our database is, it probably sits at maybe about 1.2 or 1.3 terabytes right now, and if we added transaction receipts, it would probably double in size very easily with the transaction receipts, depending on how we stored them. So yeah, so we had to hit the nodes as well in order to get the data that we put into the NFT data set. And yeah, as I said, we crawled the transfer events, we dumped them into the SQLite database as a time series, and then we had a bunch of derived data that we calculated from that time series. Everything else was derived from the time series. And we actually published a PyPy package. So if anyone uses Python, you can just do pip install NFTs, and that contains all of the tools that we use to build the derived time series or the derived data from the raw transfer time series. It took us about, as I said, 2 weeks to build this entire data set and do the analysis. Just in case you're doing similar crawls, to give you a benchmark for how long you should expect it to take. Most of that time was just spent waiting for the crawlers to finish their work. And if you do go to our GitHub, our stack is primarily Python, Go, and JavaScript. We're starting to add a little bit of Rust into the tool chain, but that's if you're at home with any of these languages, I think our code base should look very familiar to you. And then what did we learn from the first version of our NFT research? By the way, if you have any questions, you should feel free to ask them. I really don't mind being interrupted. The one question that I do see is, how would we get a recording of the meeting? I believe Peter puts them up on YouTube. Yeah, okay, just send you a link. So that's how you do it. But if you have any questions, feel free to ask them in the chat or interrupt me. I'm okay with that. So what did we learn? So we were operating at the level of just very basic statistical information. And what we found is that the sort of NFT activity and NFT purchases in the window for which we were analyzing the Ethereum NFT market did indeed follow a power law distribution. So, first of all, 17% of the addresses that were active in that period in the NFT markets, they took ownership of 80% of all the NFTs that were traded during that period between April 1st of last year and September 25th of last year, which is quite interesting. I mean, it sort of shows that the market dynamics on the NFT markets, because we didn't really know what to expect when we were going into this. And you hear all these stories of wash trading and and whales. How big is a whale really? It's hard to understand when you hear all of the hype around NFTs, exactly what shape the NFT market has. Is it a bunch of people like just random people off the street that are just like going crazy and buying NFTs left and right? Or is it a small number of people like, what I expect the art collector community to look like, who are just grabbing like the vast majority, like 95% of NFTs and causing hype to inflate prices or for some other purposes? Or does it look something like this? This is the kind of distribution that you actually see on an open market, this kind of a power law distribution. For example, this is the same distribution that you would see if you wanted to calculate like how much revenue books on Amazon generated, over a particular window of time or something like that. And so it was sort of pleasantly surprising to see that the same sort of open market distribution in terms of ownership of NFTs, it was reflected on the Ethereum NFT market as well. So that was something that we didn't really know what to expect when going into this, and it was interesting to find out that this was indeed the case. And this is, this is sort of like the standard Pareto principle sort of thing. 20% of people do 80% of blah. But there are more rigorous tests for, does something follow a power law? And usually a good test of whether a distribution follows a power law is you take the log of, the log of the amount of, X owned versus the log of the number of, like, the rank of the people that own X. And if it looks linear like this, if it follows this kind of a roughly linear pattern, then that's actually like a much better indicator that you actually have a power law on your hands. I estimated the power as well. Like in the power law, it was something like 11 or 12. So that's somewhere in that range. So we genuinely do have sort of power law dynamics in the NFT markets, or at least we did between April 1st of last year and September 25th of last year. And another thing that we discovered while we were doing this analysis was, I mean, I wouldn't call it a discovery, actually. It's something that we're still in the process of testing, is we wanted to come up with, Horacio, let's see, do you do anything to ensure that different addresses aren't owned by the same person / organization? In the first version of the analysis, we did not do anything actually to try and group addresses together if they belong to the same person or the same organization. In the next version, we are planning to. I don't think it. A power law of 12. I think that was just a piece of trivia. I don't really know how to make sense of it, and there's also like. It just tells you like how fat the tail is, but like, regardless of what power it is, it's still like a fat tail to the distribution. But the lower the power, the fatter the tail, basically. So that's all it means. But it's just a piece of trivia as far as I'm concerned. I don't really know how to interpret it beyond that. But just in case you wanted to know where that power was for the Ethereum market between April 1st of last year and September 25th of last year, it was like something like 12. But yeah, I don't know how to interpret that any further. Yeah, we didn't do any analysis actually to try and identify whether addresses were owned by the same person. But if you actually look at the paper, you'll see that it's pretty hard to justify that, like, there's a lot of bot activity going on for most of the collections. For most collections, it's most likely, just given the number of addresses that just own like more than 5 NFTs is actually pretty small, right? That's the whole point, that we have a fat tail on this distribution. So it really looks as if most of the activity is human activity as opposed to bot activity. We have found, how to identify sort of vault accounts, when somebody purchases a bunch of NFTs in one account and then consolidates them all into like some separate account. This is a pattern that you see a lot with guilds, for example, with Yield Guild games and similar guilds. This pattern is often repeated. We also have like some techniques that by analyzing gas prices that we can use to identify bots, just because the way that bots set gas is generally more predictable than the way that humans set their max fee per gas and max priority fee per gas and so on. So we do have like some techniques like that. I don't think we'll develop them any further for even for version 2 of our research, but that'll probably come sort of in the future in the next installment, because there's just so many different things going on in this market that that's not particularly interesting to us, at least in terms of publishing as research. That is much more interesting to us in terms of securing the economies that we support, right? So it's really important for us to. I don't have anything actually against bot activity. I think bot activity is very healthy. I run several bots myself, so I don't think like bot activity is inherently bad, as a lot of people do, but I don't. But being able to shut down malicious bots. I mean, bots are more likely to be malicious. Bots are more likely to be looking to expose vulnerabilities in a protocol or in a smart contract. So it is useful to know which address is a bot and which address is not a bot, in order to be, just to have your sort of to be more alert about what the threats are to your economy. So we are interested in that, but probably not for the next installment of the research. That'll come in the future installment. But one thing that we were interested in last year, and we're still interested in, is how do we tell when an NFT actually has utility, or when it's basically like, when people are buying it. How to tell when someone is buying an NFT because it actually gives them something tangible and useful when they make the purchase, and how to tell when they're buying an NFT just because they want to speculate on its price, or they want to become 100 times richer and retire, or something like that. They're just hoping for something good to happen with that NFT. And the metric that we use to actually measure this is we call it the ownership entropy of the collection. So we don't measure this at the level of individual NFTs. We measure this at the level of ERC 721 contracts. And the way that we measure it is we calculate the information theoretic entropy. So if we take, if we just consider the ERC 721 contract as, as a uniform probability distribution over its tokens, right? So we can say that, let's say that I have a contract over here that has like 42 tokens. Okay, let's just say I have 42 tokens in my ERC 721 contract. I can treat that contract as a probability distribution, which allows me to select each of those tokens with a probability of 1/42, right? So that's the way that I can think of the NFT collection as being a probability distribution over the tokens. Now, if I think of it as being a probability distribution of the tokens, it also induces a probability distribution over the token owners, right? Let's say that, like, out of these 42 tokens, Peter owns 41 of those tokens, and I only own one of those tokens. Then the NFT contract induces a probability distribution which chooses Peter with probability 41/42, and which chooses me with probability 1/42. So that's the probability distribution that an ERC 721 contract induces on the people who own tokens in that contract. And then what we do is we measure the information theoretic entropy of that probability distribution. So the information theoretic entropy of a probability distribution, it's like a really nice mathematical quantity that, what it intuitively does is it measures how spread out the probability distribution is, how evenly spread out the probabilities are over the outcomes, right? So a probability distribution which, the probability distribution where Peter is selected with probability 41/42, and I'm selected with probability 1/42 is not very even, right? It's like very highly concentrated. It very highly favors Peter, and it really doesn't favor me. So that has very low entropy. The probability distribution that has the maximal entropy over, me and Peter as outcomes is the one that selects Peter with probability 1/2 and me with probability 1/2. And basically, entropy is like a mathematically precise and rigorous way of quantifying how well spread out a probability distribution is that accounts for, like, a lot of things, and it's sort of mathematically canonical. So that's the quantity that we use to measure the utility of the tokens. And we actually found it to be a very effective tool. Actually, this table doesn't really do it justice because it seems like I've just sorted everything by the number of owners. But actually, I always regret that I didn't make this table just a little bit larger, because then you'll actually see that there are NFT contracts that have basically fewer owners than the ones that come after them in ownership entropy that actually have high ownership entropy. I actually believe the Yield Guild Games governance token is one of them, and the Rarible governance token is one of them, where they don't have too many owners, but they actually have really high ownership entropy because they actually do bring genuine utility. Being an owner of those tokens gives you, a right to earnings or a right to yield for participating in on those platforms, and they genuinely do have utility. But yeah, so the ownership entropy is measured in bits, and so the Ethereum name service actually has the highest ownership entropy out of all the NFTs that were active between April 1st of last year and September 25th of last year, and it has almost 14 bits of entropy, which is really good. It has it's selecting almost evenly across the people who own ENS domains. I think it's because ENS domains are actually pretty hard to buy. I think the way that they've done the pricing is actually quite effective in making it difficult to squat ENS domains or squat attractive ENS domains. And so people are only buying ENS domains for the most part if they intend to do something with those ENS domains. And so you actually see a lot of utility for ENS. And then, yeah, you have these governance token, the Uniswap V3 liquidity pool position token, where you can sell your position inside a liquidity pool without having to remove liquidity. All of those things have very high liquidity. And then the funniest one we found was the World Cup token. It seems like this was released for the previous World Cup, and it didn't have any activity on it, and it had very low entropy as well. It was the few people who had minted it just held that NFT. This was before all of the bubbles and all of the booms. So it's like an NFT from a more innocent age, I guess, is the World Cup token. And then ShadyCon is a more recent one. So this is Eminem tried to release some sort of an NFT, and I think it failed miserably, at least as of September 25th of last year. I don't know what's happened to it since then, but I don't expect much has happened to it since then. So yeah, that was sort of a more interesting thing that we somewhat validated using the first data set, and this is something that we're in the process of. The notion of ownership entropy as a measure of utility of NFTs is something that we're sort of really evaluating again with the second version of this data set as well. So that's those are some of the things that we found. The utility level is measured using this concept of ownership entropy, Peter. So this is where you take the information theoretic entropy. How spread out is the ownership of the NFTs across the people that own it? How even is that?
Yeah.
That's it. Mm-hmm.
Okay. All right. Sorry, I was just so essentially that level column is really just putting into words what's in the entropy column.
Exactly.
Okay.
Yeah,
all right.
Exactly. Yeah. The level is just I should have colored them or something. Normally I would color them, but I couldn't figure how to color them in a deck table. So I just put a level column there to describe it. Yeah.
Okay.
Yeah. So those are some of the things that we discovered. And yeah, as I think I had links earlier, but I put the links here again. If you want to read the paper, we go into a more detailed description of how we did the calculations, how we collected the data, and so on. And we have the code on our repository that you can use to reproduce that analysis in a different window of time if you want, and that you can use to build your own data set if you would like. You can use the code to build the data set on any sort of Ethereum-based chain, right? Anything that's using if for example, if you can run a Geth node on it, you can just connect all of these tools to your Geth node and start crawling the data for whatever Binance Smart Chain or Polygon or even Optimism. I think you can probably do it, or Arbitrum. You can build these data sets for those markets on any chain that supports the Ethereum JSON RPC, the Geth JSON RPC endpoints, basically. And yeah, same links. But let's talk about what we learned since then, unless there are more questions. You cannot access GitHub under Moonstream path. You should be able to. The organization is called bugout-dev. So maybe that's it's github.com/bugout-dev/Moonstream. That's I think once Peter sends out the link to the file there, once Peter sends out the file, you'll just be able to click on the link. Okay. So yeah, what have we learned since then? So the first thing is we learned that when we want to try and estimate the value of NFTs away from Ethereum, we need to account for ERC20 tokens being sort of the way that value is transferred rather than the native token. So for example, on Polygon, for Matic token to not be, so for people not to be using the Matic token to transfer value for the NFT purchase, they just use the Matic mostly for gas. But they use wrapped Ether or some other ERC20 token in order to actually transfer the value, or USDC, you know, or whatever. On Polygon, it's wrapped Ether because that's what OpenSea uses on Polygon. So that's sort of the forcing dynamic over there. The other thing that we discovered is that, yeah, as I said earlier, the way the patterns in which gas is submitted, the gas fees are set on transactions, is a good indicator as to bot activity. Usually bots are setting like very high gas, and they're using the same gas settings on multiple transactions. There's not like very much fancy gas work going on. That, you know, one thing that the transfer activity didn't show us was what marketplaces were people using. You know, I mean, OpenSea is the dominant marketplace, but what are the other marketplaces that people are using, or for particular NFTs, or for particular types of NFTs, you know, which marketplaces are like the go-to places for those tokens. So for that, we also need to crawl approval for all events on the ERC 721, which we're doing for the second version of the data set. We're in the process of doing that right now. And then we actually had like just other people use the data set to actually find some pretty interesting stuff. So there's someone in our community that used our data set to identify wash trading. So that's when one person just, you know, has a few different accounts and they just sell the NFTs to themselves. Then they accept, like, you know, whatever they lose to the OpenSea, like, you know, commission. But so they're losing 2.5% of, like, you know, whatever of their transaction value, but the rest of it just generates enough activity on the NFT to bring more people like into their project. And so they were able to use our data set to identify the level of wash trading that was taking place in the NFT markets. And so we're like working on making that a little bit more official, but that's really interesting work. I think they're going to publish it, although I'm not sure what the status of that is. If they do, I mean, we'll post about it in our Discord, because it's actually pretty cool work. And then we've discovered that we can use this to identify guild accounts like YGG and so on, because they usually go through, you know, the way that these guilds work usually is that some of them are very automated and others are not very automated. But what usually happens is that they'll either have like an army of bots, or they'll have an army of people go and participate in NFT sales, and then they'll consolidate all of those NFTs under a single account. And so, you know, it's pretty easy to identify that kind of activity and to like observe the patterns of that kind of activity. And it's quite interesting as well. So these are the things that, like, you know, these are the ways in which we wanted to build on our data set, on our analysis. And yeah, so in version 2 of the data set, we're going to be focusing not just on Ethereum NFT activity, but also on Ethereum activity and Polygon activity. We want to understand sort of the relationship between the activities in NFTs on those two blockchains. And we also want to understand sort of the bridging activity between NFTs between the two blockchains. I suspect that as of now, there isn't much interesting bridging going on between NFTs on one blockchain to NFTs on another blockchain. And the reason is, like, you know, what Peter was talking about it like right before this call started, where, like, you know, how do you pay out royalties from one chain onto like to an account and an owner on the other chain, or, you know, those kinds of things. There are a lot of issues that still need to be sorted out. But yeah, we're going to be doing that as part of our analysis. We're also going to be doing a longer analysis window. So we're actually crawling not just the transfer events, but also the approval for all events on ERC 721 transactions. And we're going to be doing it from January 2021 until present day. So present day will likely be, I don't know, mid-March of this year or so. We also want to do an estimation of how much bot activity there is in different projects using the gas price, using sort of those gas patterns, although I'm not sure if we'll be able to fit it into version 2 of the research. And then we want to do the wash trading estimation that our community member found, you know, the technique that they found in order to do it. So that's sort of what we're targeting for version 2 of the data set. If you have questions, or if you're just interested in participating or anything like that, just join us on Discord and message me. I'm Zonglings. That's my talk. I have 2 slides that tell you what's coming up. I don't know, Peter, do you want to go through these slides?
Yeah, I'll go through these slides. Yeah. So first of all, thank you for an awesome talk. And yeah, and we will, so I'll quickly go through these slides and then we'll switch to open questions. But, you know, we've got heaps of time. All right, so as someone asked, is this talk going to be on YouTube or somewhere like that? Yes, it is. We've got a Slack workspace, so if you want to discuss the talk and ask questions, that can be a good place to talk about it, or you could put a comment on the YouTube video. If you want to get access to future talks and register for them, then please go to the meetup.com. And so from time to time, we do switch events. So I encourage you to actually register on meetup.com rather than maybe assuming that the dates that are in the slides here are correct. And there are some, from time to time, we do example code, and that's available in that repo. Next slide, please. So the forthcoming talks that we've got. So, so this was the 99th talk, Niraj. So there you go. No, 99th talk on the 22nd of the 2nd.
Yeah.
So there you go. But yeah, so next, in 2 weeks' time, we're going to have a talk. Actually, no, it's 99. This is 98. The next
this is 98,
2 weeks
yeah,
is 90. Yeah. And then we've got Mikhail talking about the merge, which is going to be pretty good. And so some people have asked a lot of questions. And so I've fired them through, and Mikhail's going to try and answer them all. Then we've got Lex is going to give a talk. So for those people who are in Americas, this is going to be super late for you, but it's early morning in London. So it's 8:40 p.m. Brisbane, which is, I don't know, 1 a.m. or something if you're on US East Coast. But he's the chief economist at Consensus, and I know I've heard him give a few talks, and he's incredibly insightful. And so I encourage you, even if you're up at 4 a.m., it's probably going to be a worthwhile talk to listen to, or maybe listen on YouTube. But if you're actually live on the Zoom, then you'll be able to ask him tricky questions. Which, you know, I don't think it's often that you're going to have the chief economist of Consensus available for open questions. So we've got a few companies that are doing things in the blockchain space. They're going to come along, talk about what they're doing, maybe provide the architecture of their technologies and have a talk about it. Then I'm going to talk about Ethereum gas usage. There's going to be another talk about Solidity security, and there is likely to be a talk on law around NFTs. So there's actually some lawyers have done a really good article. In fact, I might even get them to do the introduction to NFTs followed by their talk. And so it's, I think they've captured a lot of the space, so it's really interesting, and we're trying to negotiate on time at the moment, so that'll probably be in May, but we'll see. So I've talked for a bit, and I guess you might as well unshare your slides and let's see what questions people have.
I guess I see a question from Horacio on chat, which is, do you offer access to your DB, or do you only offer reports and dashboards based on it? So right now, we're actually in the process of rolling out a change where you can actually submit queries that you would like to run against the data. We are serving also like production data for our customers from there, but you'll be able to get the results of approved queries whenever you want them. We're also in the process of rolling out basically replication. So we want to decentralize all of our operations, and we're in the process of decentralizing all of our operations. And so step one for decentralizing our database is we're making it easy for people to run read-only replicas of the database, as long as, you know, so if you want to run a read-only replica, or if you want to run a replica of our database, we're going to open that up to anybody that would like to do so. under the condition that we have read-only access to the replica as well, so that we can serve our API traffic through there. But that's something that we're working on. And then eventually, even the rights, we're working on so our data, the Moonstream database is a Postgres database. It's actually one very large, slow Postgres database and one small, fast Postgres database. That's the way that we operate. And so we're also in the process of decentralizing the write-ahead log for the database, so that multiple people, so that we can put a consensus mechanism into the data that gets written into the database. So we're in the process of doing all those things. Right now, though, if you want to run queries, we will very soon, I think at the end of next week, have the feature available in Moonstream in the web app, where you can submit a query, and then once we approve it, you can actually keep on viewing the results of that query at whenever you desire. I hope that answered your question.
Yeah, I have a question.
Mm-hmm.
Hopefully it's not a personal one. What NFTs do you own any NFTs? Which I think the answer is yes. So
I do. Yeah.
What NFTs do you own? And, what are your thoughts about, which NFT, if I'm sort of I've got one NFT, which, so I'm not exactly a solid representation. But what NFTs do you think are worth owning, and why would, which NFTs do you own, and why do you own those NFTs?
I think this is a fantastic question, actually. I'd love to talk about this. So I believe I don't own any art or collectible NFTs, just because I don't really understand it. I don't really understand, I don't understand Bored Ape Yacht Club. I don't understand CryptoPunks. I don't really understand the value of those things, and which is not to say that there isn't value. It's just value that I don't understand because of my personality or because of the way that I think, and because I don't understand them, I prefer not to sort of play that game. What I do believe in are gaming NFTs, because with gaming NFTs, you can really you can understand where the utility of these NFTs is going to come from, based on the extent to which the team that's developing the game or the community that's forming around the game actually are delivering on their milestones, the building experiences where the NFTs have value. The reason I like gaming NFTs is because essentially you can treat your gaming NFT as a future on the economy of the game that they're a part of, right? So because generally, if you have a gaming NFT, you can utilize the gaming NFT to earn ERC20 tokens, within the game economy. You can trade those ERC20 tokens for USDC or Ether or whatever you want, and immediately realize some value from having that NFT. And your ability to capitalize on ownership of the gaming NFT is just equal to your skill at writing programs, right? So basically, for the gaming NFTs that I own, I have a series of bots that run on my on my machine or on various machines that actually earn money by performing actions with those NFTs. And so those are the NFTs that I usually go after. And to be honest, the ones that I go after are the ones that are our customers. Those are the ones that I believe in the most, because those are the ones that we even agreed to work with in the first place, because there's just a lot of right now noise on the market, and it's important to be selective with the projects that you participate in, because I guess everyone over here is an engineer. Your attention is much more valuable right now than probably anything else, because this is the phase where this is the phase to build things on the blockchain, right? And so your attention is really probably far more valuable than anybody realizes. So yeah, I'm very careful and very selective about which projects that I even which projects I even pay attention to.
Okay, thank you for that very insightful and interesting answer. Are there any other questions?
Yeah, this is Babu here. Neeraj, thank you. It is a nice talk. Again, I'm in the same boat as Peter's thing. There is a lot of NFT things going around. A lot of time I confuse with what is the project as NFTs, and to qualify, for me, to qualify to be an NFT, it should be a unique thing and not just a token. But a lot of the time I can see they are kind of sits in the space of token, but they are projecting as an NFT. Are you guys thinking in the same line, or?
Well, the thing is, like, the actual definition of an NFT is quite cut and dry, at least as far as the Ethereum blockchain is concerned, right? So basically, an NFT is an ERC 721 contract. It needs to be an ERC 721 contract. It can have some additional functionality, but generally that additional functionality should not make tokens on the contract fungible with each other, right? So I think that's the technical answer to your question. I guess, like, more philosophically, I don't think it's actually that important. I don't think, like, the distinction is actually very important, because ultimately, like, what are you presented with? You're presented with, like, some sort of an opportunity, right? So, like, if you consider some sort of a blockchain project, it doesn't matter whether it's, like, what the tokens are involved, or, like, whether it's an NFT or not an NFT, or, this or that. What really matters is to understand, like, what are the economics sort of driving the project? Is decentralization important? Are they sufficiently decentralized? Like, those are sort of the macro level things that I'm generally thinking about, and the actual tokens themselves don't matter. And then if I'm building a project, then we have like a wonderful menu of, like, contracts to already choose from, a functionality to already choose from that we can build on top of, and then you just have to select the thing that sort of works right for your use case. So in that sense, I don't worry too much about whether something is an NFT or not. I'm just trying to understand, like, what are the underlying dynamics of the project, rather than, is it an NFT or is it not an NFT? So I think on the technical side, it's, like, pretty precise. The definition is, like, I think, reasonably precise. And on the philosophical side, I actually think it doesn't matter. Yeah.
Right. Okay. Thank you.
Yeah.
Okay, I think we've run out of questions, which means that everyone is fully across it all, which is fantastic. So, look, thank you very much again for your time. This was a very awesome talk, very good. So thank you very much, and have a great 2 weeks, everyone. Talk to you later. Bye-bye.
Thank you, everyone. Bye.
Thank you very much.
Thank you.
Bye.